The database is a vital part of any software product. There are so many databases available in this era. Many organizations are offering a database as a service. One of the giants is Microsoft Azure, as it is rich in services and features. Hello everyone, this is Dhruv from Edureka, and I welcome you all to this session where I will be talking about Microsoft Azure Database Services. So without any further ado, let's take a look at today's agenda. We will start this session by first having an overview of Microsoft Azure as well as of a database. And then we will understand the different types of Azure databases and the Azure Database Services architecture. And then we will briefly understand different database services provided by Azure and their use cases. And then finally, we will deploy an Azure database service hands-on. So first, let's get an overview of the Microsoft Azure. Microsoft Azure, formerly known as Windows Azure, is Microsoft's public cloud computing platform created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft managed data centers. It provides software as a service, platform as a service, and infrastructure as a service that can be used for services such as analytics, virtual computing, storage, networking, and much more. It can be used to replace or supplement your on-premise servers as well as it can support many different programming languages, tools, and frameworks, including both Microsoft-specific and third-party software and systems. Azure uses large-scale virtualization at Microsoft data centers worldwide, and it offers more than 600 services. Now let's have an introduction of a database. First, let's understand why do we need a database. So the various reasons a database is important are, first of all, it manages large amounts of data. A database stores and manages a large amount of data on a daily basis. This would not only be possible using any other tool such as a spreadsheet, as they would simply not work. Second is its accuracy. So a database is pretty accurate as it has all sorts of built-in constraints, checks, etc. This means that the information available in database is guaranteed to be correct in most cases. It's easy to update data in a database. So in a database, it is easy to update data using various data manipulation languages available. One of these languages is SQL. For the security of data, so databases have various methods to ensure security of data. There are user logins required before accessing a database and various access specifiers. These allow only authorized users to access the database. So fifth is data integrity. This is ensured in databases by using various constraints for data. Data integrity in databases makes sure that the data is accurate and consistent in a database. The last is easy to research data. It is very easy to access and research data in a database. This is done using data query language, which allow searching of any data in the database and performing computations on it. Now that you have understood the need of a database, let's briefly understand what actually it is. So a database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by a database management system. Together, the data in the database management system, along with the applications that are associated with them, are referred to as a database system, often shortened to just a database. So data within the most common types of database in operation today is typically modeled in rows and columns in a series of tables to make processing and data querying efficient. The data can then be easily accessed, managed, modified, updated, controlled, and organized. Most databases are a structured query language for writing and querying data. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. Databases are used to hold administrative information and more specialized data such as engineering data or economic models. Example includes computerized library system, flight reservation system, computerized past inventory system, and many content management systems that store websites as collection of web pages in a database. Now that you have an understanding of Microsoft Azure as well as of a database, let's now take a look at different types of databases in Azure. First is relational database. A relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on the relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. The columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish the relationships among data points. In a relational database, all data is stored and accessed via relations. So relations that store data are called base relations, and in implementations are called tables. Other relations do not store data but are computed by applying relational operations to those relations. These relations are sometimes called derived relations. In implementations, these are called views or queries. Derived relations are convenient in that they act as a single relation, even though they may grab information from several relations. Each relation or table has a primary key, This being a consequence of a relation being a set, a primary key uniquely specifies a tuple within a table, while natural attributes are sometimes good primaries. So this is all about relational database. Then second we have is non-relational database, also known as NoSQL databases. So NoSQL database or non-relational database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in relational databases. So non-relational databases are increasingly used in big data and real-time web applications. And non-relational databases are also like sometimes called not only SQL to emphasize that they may support SQL-like query languages or sit alongside SQL databases. So the prominent non-relational databases provided by Azure is Cosmos database that I will explain you further in this video. And third is in-memory database. So an in-memory database, also like in the short form we say it as IMDB, also like a main memory database system, or MMDB, or memory resident database. These are all the names of it. So an in-memory database is a database management system that primarily relies on main memory for computer data storage. It is contrasted with database management systems that employ a disk storage mechanism. In-memory databases are like faster than disk optimized databases because disk access is slower than memory access. The internal optimization algorithms are simpler and execute fewer CPU instructions. Accessing data in memory eliminates seek time when querying the data, which provides faster and more predictable performance than disk. A potential technical hurdle with in-memory data storage is the volatility of RAM, specifically in the event of a power loss, intentional or otherwise. Data stored in volatile RAM is lost. With the introduction of non-volatile random access memory technology, in-memory databases will be able to run at full speed and maintain data in the event of power failure. Let's now understand the architecture of database services provided by Azure. So you can see it looks like a complex architecture, but I will explain you quite easily. So the basic fundamental building block that is available in Azure is the SQL database. So Microsoft offers this SQL server and SQL database on Azure in many ways. We can deploy a single database, or we can deploy multiple databases as part of a shared elastic pool. You can see the elastic pools and single database. Okay. Microsoft introduced a managed instance that is targeted towards on-premises customers. So if we have some SQL databases within our on-premises data center and we want to migrate the database into Azure without any complex configuration or ambiguity, then we can use a managed instance. Because this is mainly targeted towards on-premises customers who want to lift and share their on-premises database into Azure with the least effort and optimized cost. We can also take advantage of licensing we have within our on-premises data center. Microsoft will be responsible for maintenance, patching, and related services. But in case if we want to go for the infrastructure as a service for the SQL server, then we can deploy SQL server on the Azure virtual machine. If the data has a dependency on the underlying platform and we want to log into the SQL server, in that case, we can use the SQL server on a virtual machine. We can deploy a SQL data warehouse on the cloud. Azure offers many other database services for different types of databases such as MySQL, MariaDB, and also PostgreSQL. Once we deploy a database into Azure, we need to migrate the data into it or replicate the data into it. Okay. Then we have is Azure Database Services for data migration. So services that are available in Azure, which we can use to migrate the data from our on-premises SQL server into Azure. So in that, the first one is Azure Data Migration Service. So it is used to migrate the data from our existing SQL server and database within the on-premises data center into the Azure. Then we have is Azure SQL Data Synchronization. If we want to replicate the data from our on-premises database into Azure, then we can use Azure SQL Data Sync. Then we have SQL Stretch Database. So it is used to migrate cold data into Azure. SQL Stretch Database is a bit different from other database offerings. It works as a hybrid database because it divides the data into different types like hot and cold. So hot data will be kept in the on-premises data center and cold data in the Azure. Then we have is Data Factory. So Azure Data Factory is used for ETL, means transformation, extraction, and loading. So using the Data Factory, we can even extract the data from our on-premises data center. We can do some conversion and load into the Azure SQL database. Data Factory is an ETL tool that is offered on the cloud, which we can use to connect to different databases and like extract the data or transform it and load into a destination. Then there's Azure Security Center. So all the databases that exist in Azure need to be secured, and also we need to accept connections from known origins. For this purpose, all these database services comes with firewall rules where we can configure from which particular IP address we want to allow connection. We can define those firewall rules to limit the number of connections, and also reduce the service attack area. So now let's talk about the Cosmos DB. So Cosmos DB is nothing but a SQL data store that is available in Azure, and it is designed to be globally scalable and also very highly available with extremely low latency. Microsoft guarantees latency in terms of reading and writes with Cosmos DB. For example, if we have any application such as IoT or gaming, where we get a lot of data from different users spread across globally, then we will go for Cosmos DB, because Cosmos DB is designed to be globally scalable and highly available, due to which users will experience low latency. Finally, there are two things, and one is we need to secure all the services. For that purpose, we can integrate all these services with Azure Active Directory and manage the users from Azure Active Directory also. To monitor all these services, we can use the Security Center. So there is an individual monitoring tool too, but Azure Security Center will keep on monitoring all these services and provide recommendations if something is wrong. I hope the architecture of Azure Database Services is now clear to you. Now let's move forward to briefly understand the database services provided by Azure. So the first is the Azure SQL Database. So SQL Database is the flagship product for Microsoft in the database area. It is a general purpose relational database that supports structures like relation data, JSON, spatial, and XML. The Azure platform fully manages every Azure SQL database and guarantees no data loss and a high percentage of data availability. Azure automatically handles patching, backups, replication, failure detection, underlying potential hardware, software, or network failure, deploying bug fixes, failovers, and database upgrades and other maintenance tasks. So there are three ways we can implement our SQL database. So first is managed instance. This is primarily targeted towards on-premises customers. In case if we really have a SQL Server instance in our on-premises data center and you want to migrate that into Azure with minimum changes to our application and the maximum compatibility, then we will go for managed instance. Second is single database. So we can deploy a single database on Azure, its own set of resources managed via a logical server. Okay. Then we have is elastic pool. We can deploy a pool of databases with a shared set of resources managed via logical server. We can deploy the SQL database as an infrastructure as a service. That means we want to use the SQL server on Azure virtual machine. But in the case we are responsible for managing the SQL server on that. But in that case, we are responsible for managing the SQL server on that particular Azure virtual machine. So then we have the purchasing model. So there are two ways we can purchase the SQL server on Azure. So first is vCore purchasing model, also known as virtual core purchasing model. So the vCore purchasing model enables us to independently scale compute and storage resources, match on-premises performance, and optimize price. It also allows us to choose a generation hardware. It also allows us to use Azure hybrid benefit for SQL server to gain cost savings. Best for the customers who value flexibility, control, and transparency. So second is the DDU model. It is based on a bundled measure or compute storage and input-output resources. So sizes of the compute are expressed in terms of database transaction units, means DTUs, for single databases, and elastic database transaction units for elastic pools. This model is best for customers who want simple pre-configured resource options. And the second database service is Azure Cosmos Database. So Azure Cosmos Database is a NoSQL data store. It is different from the traditional relational database where we have a table and the table will have a fixed number of columns and each row in the table should adhere to the scheme of the table. In the NoSQL database, you don't define any schema at all for the table. And each item or row within the table can have different values or different schema itself. So now let's understand the Cosmos database structure. First one in the structure is a database. So we can create one or more Azure Cosmos database under our account. A database is analogous to a namespace, and it is the unit of management for a set of Azure Cosmos containers. So the second is Cosmos account. So the Azure Cosmos account is the basic unit of global distribution and high availability. For globally distributing our data and throughput across multiple Azure regions, we can add or remove Azure regions from our Azure Cosmos at any time. I mean Azure Cosmos account at any time. So the third is a container. So an Azure Cosmos container is the unit of scalability for both provision, throughput, and storage of items. A container is horizontally partitioned and then replicated across multiple regions. Then let's understand the types of consistency under Cosmos DB. So Azure Cosmos Database approaches the data consistency as a spectrum of choices instead of two extremes. So strong compatibility and eventual consistency are at the ends, but these are many consistency choices along the spectrum. So the consistency levels are region agnostic. The consistency level of our Azure Cosmos account is guaranteed for all read operations regardless of the region from which the reads and writes are served. The number of areas associated with the Azure Cosmos account, or whether our account is configured with a single or multiple write regions. Then there's request units. So we pay for the throughput we provision and the storage we consume on an hourly basis with Azure Cosmos DB. Remember, this DB means database. So then there are request units in Cosmos DB means Cosmos database. So we pay for the throughput we provision and the storage we consume on an hourly basis with Azure Cosmos DB. The cost of all the database operations is normalized by Azure Cosmos DB and is expressed in terms of request units. The price to read a 1 KB item is one request unit. All other database operations are similarly assigned with a cost in terms of research units. The number of research units consumed will depend on the type of operations, item size, data consistency, query patterns, etc. For the management and planning of capacity, Azure Cosmos Database ensures that the number of research units for a given database operations over a given dataset is deterministic. And the third database service is Azure Data Factory. So Azure Data Factory is a data integration service based on the cloud that allows us to create data-driven workflows in the cloud for orchestrating and automating data movement and data transformation. Data Factory is a perfect ETL tool on cloud. Data Factory is designed to deliver extraction, transformation, and loading process within the cloud. The ETL process generally involves 4 steps. So the first one is collect and collect. We can use the copy activity in a data pipeline to move data from both on-premises and cloud secure data stores. So the second is transform. So once the data is present in a centralized data store in the cloud, process or transform the collected data by using compute services such as HD inside Hadoop, Spark, Data Lake Analytics, and machine learning. Third is publish. So after the raw data is refined into a business ready consumable form, it loads the data into an Azure data warehouse, Azure SQL database, and Azure Cosmos database, etc. So fourth is monitor. So Azure Data Factory has built-in support for pipeline monitoring via Azure Monitor, API, PowerShell, Log Analytics, and health panels on the Azure portal. So then there are components of Data Factory. So Data Factory is composed of 6 key elements. All these components work together to provide a data form on which you can form a data-driven workflow with the structure to move and transform the data. So first one is pipeline. A Data Factory can have one or more pipelines. It is a logical grouping of activities that perform a unit of work. The activities in a pipeline perform the task altogether. For example, a pipeline can contain a group of activities that ingest data from an Azure blob and then runs a Hive query and an HD Insight cluster to partition the data. So second is activity. It represents a processing step in a pipeline. For example, we might use a copy activity to copy data from one data store to another data store. Then we have is data sets. So it represents data structure within the data stores, which point to or reference the data or we want to use in our activities as input or output. Then there are link services. So it is like connection strings, which define the connection information needed for Data Factory to connect to external resources. A linked service can be a data store and compute resources. Linked service can be a link to a data store or a compute resource also. Then we have as triggers. So it represents the unit of processing that determines when a pipeline execution needs to be disabled. We can also schedule these activities to be performed at some point in time, and we can use the trigger to disable an activity. Then the last one is control flow. So it is an orchestration of pipeline activities that include chaining activities in a sequence, branching, defining parameters for the pipeline label, and passing arguments while invoking the pipeline on demand or from a trigger. We can use a control flow to sequence certain activities and also define what parameters need to be passed for each of these activities. I hope you have now understood the major services of Azure databases. So now let's have a look at some of the use cases for Azure database services. First, let's see the use cases for SQL database. So the first one is developer or test environment. An important use case for replicating or migrating data to SQL hosted on Azure is for developer or test environments. Before deploying to the production environment, it is pertinent that the data is tested against developer and test environments. So Azure SQL Database can act as a target for such environments. The live production environment can be replicated to the developer or test environment using a database copy. So the second is business continuity. One of the most important use cases for SQL on Azure is using it as a PR target to maintain business continuity. Azure SQL databases can provide an SLA of up to 99.99% by maintaining several copies of the data. This provides business continuity as it allows you to restore geo-redundant copies of the data or use active geo-redundant copies as failover points in use of outages at data centers or in regions. Besides SQL databases, you can also use availability groups to fulfill business continuity demands. Not only can you use availability groups in Azure SQL virtual machines, but also use Azure SQL virtual machine instances as a target for high availability and disaster recovery. And the third one is scaling out read-only workloads. Apart from providing BC or DR capabilities, active geo-replication can also be used to offload read-only workloads such as reporting jobs to secondary copies. You can also extend on-premises SQL Server instance using readable always-on replicas. And the fourth one is backup and restore. So Azure SQL Database are backed up automatically on a regular basis, and there are no storage costs for up to 200% of the maximum provisioned database storage. You can restore backups to any point in time going back to a pretended period which is determined by the Azure SQL Service tier in use. On-premises SQL Server databases and transaction logs can also be backed up directly to Azure using the backup to URL feature and stored in Azure storage. So Azure SQL databases can also be stored on local storage by exporting them to backpack files, means backup and restore files. So fifth one is advanced analytics. So another important reason for hosting SQL in Azure is to make use of Azure's advanced analytics platforms such as Azure Storage Blob and Azure Data Lake Store. A common scenario with advanced analytics is when users reference data from various data sources, use Azure Data Lake Store as the staging area, or perform transformation activities using Hive or Spark, and finally load the data into Azure Data Warehouse for BI and reporting. BI means business intelligence. Now let's see the use cases for Cosmos database. First of all, they are used in IoT and telematics. So IoT use cases commonly share some patterns in how they ingest, process, and store data. First, these systems need to ingest bursts of data from device sensors of various locales. Next, these systems process and analyze streaming data to derive real-time insights. The data is then archived to cold storage for batch analytics. Microsoft Azure offers rich services that can be applied for IoT use cases, including Azure Cosmos Database, Azure Event Hubs, Azure Stream Analytics, Azure Notification Hub, Azure Machine Learning, Azure HD Insight, and Power BI. Bursts of data can be ingested by Azure Event Hubs as it offers high throughput data ingestion with low latency. Data ingested that needs to be processed for real-time insight can be funneled to Azure Stream Analytics for real-time analytics. Data can be loaded into Azure Cosmos Database for an ad hoc query. Once the data is loaded into Azure Cosmos Database, the data is ready to be queried. In addition, new data and changes to existing data can be read on changed feed. So change feed is a persistent append-only log that stores changes to Cosmos containers in sequential order. Then all data or just changes to data in Azure Cosmos Database can be used as reference data as part of a real-time analytics. In addition, data can further be refined and processed by connecting Azure Cosmos Database data to HD Insight for Pig, Hive, or MapReduce jobs. Refined data is then for a sample of IoT solution using Azure Cosmos Database, Event Hubs, and Storm. See the HD Insight Storm examples repository on GitHub. Okay. Then we have is retail and marketing. So Azure Cosmos Database is used extensively in Microsoft's own e-commerce platform that runs the Windows Store and Xbox Live. It is also used in the retail industry for storing catalog data and for event sourcing in order to process pipelines. So catalog data storage scenarios involve storage and querying a set of attributes for entities such as people, places, and products. Some examples of catalog data are user accounts, product catalogs, IoT devices, registries, and bill of material systems. Attributes for this data may vary and can change over time to fit application requirements. Consider an example of a product catalog of an automotive part supplier. Every part may have its own attributes in addition to the common attributes that all parts share. Furthermore, attributes for a specific part can change the following year when a new model is released. Azure Cosmos Database supports flexible schemas and hierarchical data, and thus it is well suited for storing product catalog data. Azure Cosmos Database is often used for event sourcing to power event-driven architectures using its change feed functionality. The change feed provides downstream microservices the ability to reliability and incrementally read inserts and updates made to an Azure Cosmos database. This functionality can be leveraged to provide persistent event store as a message broker for state-changing events and drive order processing workflow between any microservices. In addition, data stored in Azure Cosmos Database can be integrated with HD Insight for big data analytics via Apache Spark jobs. So the third one is gaming. The database tier is a crucial component of gaming applications. Modern gaming apps perform graphical processing on mobile or console clients but rely on the cloud to deliver customized and personalized content like in-game stats, social media integration, and high-score leaderboards. Games often require single millisecond latencies for reads and writes to provide an engaging in-game experience. A game database needs to be fast and be able to handle massive spikes in request rates during new game launches and feature updates. So Azure Cosmos Database is used by games like The Walking Dead, No Man's Land by Next Games, and Halo 5 Guardians. So Azure Cosmos Database provides the number of benefits to game developers like Azure Cosmos DB allows performance to be scaled up or down elastically. This allows games to handle updating profiles and stats from dozens or millions of simultaneous gamers by making a single API call. Then Azure Cosmos DB supports millisecond reads and writes to help avoid any lags during the gameplay. Then Azure Cosmos Database automatic indexing allows for filtering against multiple different properties in real time. For example, locating players by the internal player IDs or their game center Facebook, Google IDs, or querying based on player membership in a guild. This is possible without building complex indexing or sharding infrastructure. Social features including in-game that messages player guild membership challenges, completed high score leaderboards, and social graphs are easier to implement with a flexible schema. So Azure Cosmos Database as a managed platform as a service required minimal setup and management work to allow for rapid iteration and reduce time to market. The last one is web and mobile applications. So Azure Cosmos Database is commonly used within mobile and web applications and is well suited for modeling social interactions, iterating with third-party services, and for building rich personalized experiences. The Cosmos Database SDKs can be used to build rich iOS and Android applications using the popular Xamarin framework. So under web applications, first we have the social applications and then we have personalization. So in social applications, a common use for Azure Cosmos Database is store and query user generated content, means UGC. So for web, mobile, and social media applications, some examples of a user generated content are chat sessions, tweets, blogs, posts, rating, and comments. Often the UGC in social media applications is a blend of free form text, properties, text, and relationships that are not bounded by rigid structure. Content such as chats, comments, and posts can be stored in Cosmos DB without requiring transformations or complex object to relational mapping layers. Data properties can be added or modified easily to match requirements as developers iterate over the application's code, thus promoting rapid development. Applications that integrate with third-party social network must respond to changing schemas from these networks as data is automatically indexed by default in Cosmos database. Data is ready to be queried at any time. Hence, these applications have the flexibility to retrieve projections as their respective needs. So the second thing in web and mobile applications is personalization. So nowadays, modern applications comes with complex views and experiences. These are typically dynamic, catering to user preferences or moods and branding needs. Hence, applications need to be able to retrieve personalization settings effectively to render UI elements and experiences quickly. JSON, a format supported by the Cosmos DB, is an effective format to represent UI layout data as it is not only lightweight but also can be easily interpreted by JavaScript. Cosmos DB offers turnable consistency levels that allows fast reads with low latency writes. Hence, storing UI layout data, including personalized settings as JSON documents in Cosmos DB, is an effective means to get this data across the wire. So these were the use cases for Cosmos DB. Now that you have a theoretical understanding of Azure database services, let's now see a simple deployment of a database service on Microsoft Azure. Just simply type Microsoft Azure on Google. What you can do is you can create a free account on Microsoft Azure. You get 12 months of free services and around 40,000 rupees of free credits also for using the services. We can just directly open the console from here. I'll just sign in. So for deploying a simple database service, so what we are going to deploy today, we can like deploy Cosmos database, like I've explained you what is Cosmos database or NoSQL database it is. So we can just go to console, to the portal I mean. You can go to the portal. You can create a resource from here. You can search for Cosmos. Comes like Azure Cosmos, yes. You can see here like free credits. I have a free trial account, so it is showing that I have 14,500 free credits. So this is the like credit amount you get for in a free trial. Okay, so you can create a Azure Cosmos DB from here. Which one you want to create? Like you can create Core SQL one. So resource group, you can give a new one, or we have an existing, we have a cosmos one, resource cosmos. So if you want to choose the existing one, or if you want to choose the new one, okay. So you can choose the existing one from here, or if you want to create a new one, then create new one. Source one cosmos. I hope that works out. Yeah. Then give any unique name for this, like I will give demo underscore cosmos 123. Okay, it cannot contain underscore. Remember these things, okay? It just cannot contain this. So 1, 2, 3, 4 I will. Okay, it's not available, so I will give 5 also. Yeah, it's available now. And like choose your location, whichever location you are located in. You can use nearby location. So mine is Asia Pacific Central India. So I've chosen this. So free trial account is already there. I applied for it. Then you can just review and create. Before getting deployed, it will show you the review for it. So remember that on the basis of the location we have selected, the creation time will differ. Okay. So you can review it, all the information what you have inserted. So now you can create. So deployment is in progress. It will take a few minutes. You can see like how the resource has been created. Deployment is in progress. Will soon be created. You can check details for it from here. Let's go to portal again. Like it is already pinned here, or you can search from here. Okay, for Azure Data Cosmos DB. So you can just click here. So it is showing that it is getting created. This is the one I have created before only. This one is creating. It is still in progress. Let's refresh one again. You can see the processing going on here. Yeah. So your deployment is complete. It's showing. You can go to resource from here also. Or you can just refresh it from here. So yeah, this is how it's been created. You can open the resource from here, and you can go to activity log or data explorer. You can create a database, anything, or you can see the consistency of it, like default consistency and everything. So that's how Cosmos database is being deployed. So I hope you have understood this deployment. With this, we come to the end of today's session of Azure Database Services. I hope you had a great time learning and understanding about it. And if you have any queries, please feel free to leave them down in the comment section below. Until next time, thank you.